Welcome. This is the last keynote of the conference. I am Karina Gibert. I'm a full professor on artificial intelligence at the Universitat Politècnica de Catalunya. And also I'm the Dean of the Professional College on Computer Science here in Catalonia as part of the Spanish Council of Professional Colleges from Spain. And I have been around 35 years making intensive research in AI and training new professionals. So they have been asking me to talk a little bit about where we are, why we are in this hype and boom on artificial intelligence. This is our research center, is Intelligent Data Science and Artificial Intelligence Research Center at the UPC. And of course, what we are living in this moment is about what we call the digital society, the building of the digital society. That's like a very big revolution on the socio-economical structures, and this is something that has been recognized by the United Nations already in 2018. And this has been possible because the very, very quick and very powerful development of certain ICT technologies that have been developing very, very quickly in very recent years. And as you know, here we have the big leverages of this transformation: IoT, wearables, 5G, cloud computing, high-performance computing, and cybersecurity. But all of them are basically creating a very nice infrastructure to get better data, quicker, safer, from all over the world, traveling easier and being accessible for many, many different points in the world. But none of them are talking about what data is about and which is the added value of this data. The one that is doing this job is artificial intelligence. That is basically something that helps a lot to disclose the complexity of the reality through the data. This is nothing new. Let me see if this works or not. This is nothing new. Artificial intelligence is something that comes from the 1956. It is very famous from very recent years, but in fact, this is a job that has been maturing from many, many years ago. And the beginning is in the famous Dartmouth Summer School that was convoked by Professor John McCarthy with these 10 persons that were very, very prominent at the moment. And the main conjecture of the, I'm sorry, but this is not marking anything. The main conjecture of the artificial intelligence was to think during these 2 months of the summer school if it is possible to specify the intelligent activities that human beings perform in such a precise way to be able to build machines that could imitate this kind of intelligent activities. So I always like to talk about that because in this conjecture, data is not part of the job. It's not part of the play. So it is until the 80s that AI has been working basically with knowledge and thinking and reasoning and not that much focusing on data. In fact, the 3 formal pillars where artificial intelligence is building today are data. And when we deal with data from more or less classical artificial intelligence, we basically inherited more or less a lot of algebraic principles, and all the machine learning algorithms are much more sophisticated than basic algebra and then basic statistics, but we are more or less in that line, in the line of using the algebraic principles to process this data. On the other hand, artificial intelligence is working with knowledge. Knowledge is something that not always can be represented by data, and the formal background when we want to represent knowledge in an AI context is the formal logics. Of course, it's a part of algebra, but here we are much more connected with reasoning and with inferential engines and all these other kind of things. And in the middle, we have, of course, the programming languages that are another formalism that allows us to transform all those methodologies into algorithms, into machines that can be executed and can work in real life. No? And doing all these things in a digital transformation context requires a huge dose of ethics in such a way that what we build with artificial intelligence do not damage human rights, basically. So basically, we have a very powerful technology that's able to help us to better understand complexity in any application field that you can imagine. And once we understand what happens, why things happen, it is very easy to better decide, to better manage, to better control, to better operate with this complexity. And that's the power of artificial intelligence. So it is providing added value in the entire value chain of solving problems, basically. And we can find many different specialities of artificial intelligence that play a role in the different parts of the problem-solving activities. One of the most unknown is how knowledge engineering helps to understand a complex problem and to formalize how to represent it, and how with the traditional machine learning or data science or other kind of artificial intelligence algorithms, we can treat this data and get solutions. But at the very, very beginning, there is also a role that AI can play just in understanding how to represent the problem to make all this machine learning more efficient, for example. No? And when we are talking about generative AI, that's one of the most famous part of AI in this moment. This is something that comes as a very sophisticated evolution of the artificial neural networks that comes from the 40s. We had some winters in the middle, but the most, the boom of deep learning happened about 2013 after the GPUs were providing the capacity to process all these artificial intelligence algorithms in a very, very quick time. And this opened the door for industrial applications. Then a little bit later, we enter into the adversarial neural networks and all the transformers and all those pillars that has been creating the generative AI that was started in the 2020s, basically. One of the first tools was DALL-E, that was based on creating images from prompts. And a little bit later, we started to have other generative AI applications that were able to create answers, textual answers from prompts as well. And in November 2022, we started with ChatGPT and all this boom of generative AI. So here you have the review that in 2020, the AI Watch was making about all the AI area. And here you can see the many different specialities and the many different research branches we have in AI. An important thing is that reasoning is always there. Planning is always there. We have today a very intensively used planner in all our pockets. That's the GPS, for example. So this is a planning algorithm that is solving problems every 2 seconds from millions of users in the world, and we have it in our pockets every day. And machine learning is something that comes around 80s, because all the traditional symbolic AI based on knowledge found a limit. That was the implicit knowledge of the expert. So we learned at the end of the 70s that we have not a way to quantify how many implicit knowledge an expert has, and we have not a methodology that guarantees that we have been extracting all this knowledge to transfer to an expert system to reason in the same way as a human. So as a kind of, what I would say, as a kind of alternative, someone said, okay, experts will never else explain how they make diagnoses or how they solve the problems. They will give us data from examples and how they make these diagnoses, and we will build a machine that takes the data, takes the diagnosis, and builds the bridge and learns how to solve the problem without asking to the experts anymore. So at the end, in the 80s, this machine learning appears, puts the data on the focus. This is, after some years, in concordance with the development of the big data technologies and all the cloud infrastructures and high-performance computing and everything was converging to providing the machines the capacity to analyze very complex data in real time and to solve many, many different problems. And one important thing that appears here is the ethics and philosophy on AI, because once the AI goes to the market and starts to build real applications that impacts persons, in this moment the ethics starts to become more relevant than before. So in this moment when we are trying to transform organizations through the adoption of AI, we have basically two views. One is how do we use AI to improve the processes inside our organization from the organizational point of view. And the other one is how do we use this AI to improve the relationships with our customers, providers, other companies, and so on and so on. What we recommend is to start by making internal transformation until the company gets a little bit of experience, because the first experience can be sometimes a little bit risky, so it's better that the risk keeps inside the doors of the company. No? It's very important, the cultural change, so introduce AI in a business needs to change the entire way of managing the business inside the company. And the other thing that has to be taken into account is how do we plan this transformation. The change management requires time, planning, and clear ideas on how to do it, because if you just change one software by another one that is intelligent, sometimes the things are not that easy. And the other thing that we recommend from Spain and from Europe in reality is that we should always think about the idea of intelligent assistant, not that much about this AI that will substitute humans, not only from a social point of view, but also from the responsibility point of view. And what we recommend is that AI, apart from robots and these autonomous machines, should be always supervised by a human that takes the responsibility of the decision and that eventually can discuss or can reject the predictions of the system if they are wrong. As you know, AI provides models. They are never working 100% of the time, so there is a little risk that in a low percentage of the real applications, the recommendation of the AI fails. So there is very important that the human takes care about that and has the criteria to decide when AI needs rejection. And the other thing that's very important is this explainability layer when we are talking about AI that is supporting decisions taken by humans. So it's not enough to get a very nice prediction with a very nice precision. We need to be able to reason about why this solution is the best, and this requires that the system provides explanations about how it has been building the predictions. This is very critical because generative AI is black box, and deep learning is black box. So now there is a new branch on AI that's called explainable AI that's exactly focusing on adding reasoning layers after these black box predictive models that are very good at predicting but cannot explain why they have been building these predictions. When we are talking about ChatGPT, for example, and all these generative AI, we can see that the increasing of users of this kind of tools is very spectacular. In this moment, we have 400 million users per week. That's very huge. We have to take into account that these systems always fail, so it's very important to review all the results. There are some activities where they are more proficient than others. One of the things that's a kind of, I don't know how to name it. One of the things that is like dysfunctional use of generative AI is to confuse it with an encyclopedic tool. So generative AI has not been creating to be Google Plus. And that's something that many people does, no? It uses it just to query questions and these things. And sometimes it hallucinates, it makes inventions, it lies, and so on. So we need to know about the topic, and we need to have the criteria to review and to decide if we adopt or not the solutions it provides, because sometimes it fails. In text generation, in language understanding, in multilingual machine translations, transcriptions of voice, conversational applications, automatic content creation, creative writing, and assisted design, it is proficient and it works quite well. No? And also it is assisting very well in this moment to coding, to programming. No? Of course, it requires every time that there is a proficient programmer, a proficient developer that supervises what it provides. There is also this risk of information leakage when we are talking about the public version. So in that case, for example, we have been working a lot on specializing chatbots for providing information about products in a company. This is no risky because the catalog of a company is public. And if this information flows to another company, there's no risk. But we also have to take into account that we don't know very well what's happening in the backend, and that critical information can be connected among several separated queries, and that then they can be provided as a new solution to your competitors, for example. So this is something that has happened. So we have to be very careful on which kind of information used in our prompts, okay? And after that, there are many other applications on artificial intelligence, not necessarily based on generative AI, that can solve different problems. Here, for example, we were identifying overflows in the Bicing lockers in the city of Barcelona with 1 day anticipation, so that the company of Bicing could install extra places the day before a very important event or something like that, to prevent the discontinuation of the service. That's one of the reasons why Bicing do not have as much enrollment or as much engagement of the citizenship as desired, for example. No? So that's one point. Here we were working on predictive maintenance. So you can imagine that when you have an unexpected failure in one aerogenerator that's on the top of a mountain, you need about 15 days to organize the expedition that goes with an helicopter to the mountain and makes the reparation. So if you can plan it just in time with some anticipation, you don't interrupt the production of clean energy so many days. No? And this is a very old project where we were proving more than 20 years ago that it was possible to have a healthcare system replicated on the ICT, like a kind of metaverse, and treating the patient and making all the system orbiting around the patient that's at home. And this was awarded in 2010 by the European Commission. And I like to talk about that because today in Spain, still, we don't have this technology completely deployed. So that's the kind of tempos that are playing in between research and real adoption in the real market. No? This is another technology that was built during the pandemics. In that case, it is based on the collection of data that comes from any kind of digitalized questionnaire. And it's a tool that puts the artificial intelligence in making the statistical analysis of the data and writing the report. So we collect the data, and this intelligent system creates the book with the whole layout, graphs and numbers and everything, so the decision maker can consume these results in about 1 hour after closing the data collection. So this is very important because it's opening the door to make public policies in front of situations where the systemic data do not provide the information we need to make the decision. So when we have this lack of data, we only have to design the questionnaire to identify la població diana, the target population, and after we collect the data, we can get these results very, very quickly. And I will enshort a little bit. So AI is very powerful to solve a lot of problems in health, in environmental systems, in public policies, and in traffic, in mobility, industry, whatever you can imagine. But it has as well some challenges because it's a very, very powerful technology. So depending on how you use it, you can get benefits or you can get some dysfunctions. No? And here, for example, it's important to understand that the quantity of data do not guarantee a better model necessarily, provided that the important thing is that the data is representative of the problem, and it doesn't matter that much, the quantity. So here we have an example from 2021 where someone was taking 300 million users from Twitter in the United States to make a sentiment analysis and understand what the people was thinking about the impeachment process from Trump. And it doesn't matter if you put the entire Twitter inside. It's not about 3 million, 300 million, or 3,000 million. 9-year-old ladies, for example, are not users of Twitter. So you will never have the opinion of the entire American society in this kind of examples, because Twitter is not representing the society, it's representing a part of it. So it doesn't matter how many data you put there. No? And the design of the data set is very important, that has a good connection with the representativeness of the kind of society or phenomenon we are trying to analyze. Here there is another idea that's also relevant. That's the anonymization, this narrow view of anonymization that we are using in the last 20 years. That's, okay, I eliminate the name, the address, the telephone, and something else from my data sets, and now I can do whatever I want with these data sets. Is not that simple. Because when you cross different data sets, it might happen that you violate the statistical secrecy, or you re-identify the individuals. And here you have an example that it even do not contain personal data anywhere. Here you have public data on the aggregated consumption of water in the buildings. And as you know that when you have a peak, you have advertisements in the TV. If you cross this information with the TV schedule, you can learn which is the TV channel that's seen in a certain building. And if the building is unifamiliar, you know the political trend of a particular person. And then you can decide about a political campaign, for example. But in that case, you can identify the political trend of a person without using any personal database. So we need a lot of caution when we are talking about crossing open data sets, because we need to be careful to don't violate the anonymization. We have another problem in AI that are all these fakes and disinformation. You know that this picture was published about 3 or 4 days before the elections in the United States, and we will never know how some persons have been changing their voting because of that. No? And then we have all this idea about biases. No? And most of us tend to think that bias is something about data, but we have many different kinds of biases. Not only the single source of bias is not only data, and here we can see some examples. So here, for example, that's a data bias. This is a soap dispenser that has been installed in the entire Marriott's hotels chain in the United States in 2017 that was not able to see the black hands. It was trained only with with images from white hands, and the black people was not detected by the sensor. No? So here the problem is that we didn't design in a proper way, the training data from the algorithm. And that's the same case. Here we have another type of bias. This is a bias of the design of the product. Here we have a video game, and here what you can see is that the warrior is something that's very well protected to fight with the aliens in Screen 25, no? Whereas the female warrior is going without dress. No? So here we are perpetuating all these gender stereotypes that change, work against equality and these kind of things, and that's why, because we have very, very few women participating in the generation of video games, for example. No? So here we have a bias, a gender bias, on the design of the technological product. Here is another one that is much more recent, and we have still all these stereotypes. No? Here we have another bias that is combining gender bias with race bias and access bias. That's another bias that generates a lot of social inequality. No? And in that case, Joy Bolamwini is a researcher on AI from the MIT that one day discovered that her cell phone have a facial recognition module that was not working with her. And she discovered that this facial recognition is not working with any black person. But this is a commercial product. You buy on a shop. Nobody tells you that there is 20% of the functions that are not available for you, and you do not get a discount for this. And so this is quite impacting the access of a particular kind of population to a commercial product, okay? And here we have another one that is a biased algorithm that is impacting in the rights of working. In that case, all those platforms that make playlists automatically, we have been discovering that they never propose new, younger female singers. They can add new, younger male singers, but not females. And since today, to enter into the market, into the music market, you need to enter through this playlist, that means that new female singers can never make a space to work in the music market. No? So this is another kind of bias that when you train in the wrong way the AI, you really can impact on how social equality, on how justice works in the world. No? Then there is another one, that's the bias of interpretation. That's not special for artificial intelligence, can also apply to other kind of data analysis. And in that case, in one of our projects, we were analyzing the impact of lockdown during the COVID into the vulnerability of the persons. No? And we got a result. Here in Spain, during the lockdown, the companies could put the people temporarily out of the company, and the government was paying for their salaries. And we discovered that few women were using this ERTO program, and many male were put in this ERTO program. No? If you interpret the plain number, you would tend to learn that women were protected by the companies during this process. But when you go backwards to January and you see the professional situation of male and female, this was a study that was done with vulnerable population, most of the women in the program were working without a contract. So you cannot put into this ERTO program a person that is illegally contracted. So you need to put all those perspectives to interpret the numbers in the proper way, because the reality was exactly the opposite of what numbers were talking about in an initial reading, let's say. No? And finally, this was a very, very disgusting situation. Maybe some of you remember that in January 2021, the government from the Netherlands was resigning, because after 10 years, some consumption associations were able to prove that an artificial intelligence that was identifying fraud in social services in the Netherlands has been for 10 years working with a bias. And it was pointing to black people coming from colonies and living in very poor areas of Amsterdam. But most of those people have not made a real fraud, no? And there were more than 26,000 families that received an accusation of fraud that was fake, was false. And most of them were going in jail, and most of them were suiciding, and most of them were just getting mental diseases, and most of them got bankrupt or divorce or other kind of consequences from when you receive an accusation that's not true. No? So I like to talk about that because this is representing many different things on what we are doing with AI. So once you are training an AI and you try to put this AI to work with persons, you need to make a very, very strict validation, very complete validation. You cannot put a system that has a bias on play. But apart from that, so you first of all have to design in a proper way these training data so that they are really representative of the population. Then, after building the system, you have to validate and test very intensively to verify that there are not other biases that appear over there. But also, it talks about the importance of this explainability capacity. So after saying this person made a fraud, this AI should explain why it is concluding that the person made a fraud. So this would have been helped a lot to understand if there was a mistake or not there. No? But then we also have the idea that the person that was operating this AI in the public services in the Netherlands government was not properly trained. He never understood that he was allowed to reject the results of an AI in front of a real situation. So you receive a person in front of you that says, I'm desperate, I'm honest, I'm not making a fraud, and I don't know what happens. And nobody was saying in any of these situations, give me your documentation and we will make a human revision. So it's not only about AI, it's also about how we insert the AI in the real settings. And this requires as well to train the people that is working with it to understand which kind of uncertainty is associated with the predictions of an AI system, even if it has a very high performance. No? And that's why this human supervision becomes so many important. And here is also a clear example that justifies why here in Europe we are so worried about ethics. Because when an AI fails, it is not about damaging 3 persons. It damages a very high number of persons in very few minutes. No? So biases at the end have always this consequence of incrementing the social inequality in one way or another one. And all powerful technologies along the history of the humanity has also created the same dilemma. So they provide a lot of benefit and they provide progress to the society, but they have also some uses that are not that nice, no? So this is the moment we are living with AI now. We are now trying to regulate which is the accepted role of AI that provides benefits to the society and which kind of uses we want to preclude to avoid damage to the person. So in the European vision of how AI should work, the red line is the protection of fundamental rights of the persons, and what the European Commission is trying to create is a framework to develop a human-centered AI for good and trustworthy. Basically, this is very different from the views of AI in China or in the United States. And the ethical framework that it's around all this idea was, the first text was published in 2019, and it is based on 7 principles. That's human agency and human oversight, robustness, safety, privacy, of course. In Europe, you know that we have very strict implementation of privacy, transparency, this diversity or non-discrimination that's related with biases, and also the societal and environmental well-being. Here we talk about the cost of AI, the environmental cost of AI, but we also have to take into account that many predictive models coming from AI helps to keep the air quality, to reduce the contamination of the traffic, to cure some diseases. So there is this double view that AI consumes a lot of energy, but it is also solving a lot of problems that helps the health of the planet as well. And then accountability is also associated with the auditability of the algorithms, just in case they fail, so we can understand what has been happening. No? And a part of this ethical model has been implemented in the European AI regulation. That's a system of risk. So any AI that's impacting with persons is from high risk or unacceptable risk. The social credit systems are forbidden in Europe, but for example, a machine that is making diagnosis or is analyzing medical images is of high risk, and it has to fulfill more testing and more certifications to go into the market. We have been making a long path from the 2017 and 16. That was the first European regulation of data protection. And now we are in the step of implementing all these European law that includes different levels every 6 months from last 1st of August. So at the end, we have to find a formula by which all this development keeps under a responsible framework, and from those that develop, those that transfer, those that make innovation, deploy, adopt, and use AI should be aware of which are the risks and which are the potentials, and it is very important in this moment to adopt this ethical framework, because law normally comes much later, but when an AI fails or when AI is done in a non very good way, the damages for the persons can be very high. So it's important to work for this worldwide governance, because we have something that's intangible that flies on the cyberspace, and it's a little bit difficult to encompass the different views from the ethics that we have in Europe, from United States and China, and we are now seeing what will happen. In last September, we were starting like a process to build a common ethical framework in between United States and Europe. Now things have been a little bit interrupted, but it's interesting to think in a global way, because we are talking about a technology that's made whatever in the world, and it is used in the other side of the world without passing frontiers and exportation procedures and nothing. So it's important to talk about that. We need a lot of development of this general culture on AI and digital transformation, and ethics and deontology and responsibility plays a very critical role in this moment, because the technology is very powerful, and depending on how we use it, we go well or we go not that well. So this is, okay, these are teams of experts where I'm working with to help our government to make this safe introduction of AI in the public administration, and also to the companies to develop in the safe way this adoption of AI. And the basic conclusions are that it is a very, very powerful tool. Not always Gen AI is the single solution. There are other forms of AI that can help according to the structure of the problems. But whenever there are a lot of free tools that we can touch some buttons and we can use. But it's important when we are trying to adopt AI to do together with the people that knows about it and about the risks and about the limitations, because the line to make something that vulnerates persons is very, very, very thin. Thank you very much.